Hey guys, this is your first flipped lesson with me. We're going to be jumping into chapter 1, section 1. Before you've done this video, I hope that you watch the helpful hints video where it has a few reminders on when to pause, how you could go back and watch things on the video, how I'm going to screw things up, and such and such. So if you have not watched that video yet, I'd encourage you to pause and go back and watch that video now. Before we jump into this one, I just want to give you a heads up. About the next, 3, 4, 5 weeks or so are going to be very, very heavy review. We're going to be going through the stuff that you did last year in pre-algebra at an ultra fast pace. So it's very important that you keep up with the notes, that you're paying attention. Just because you think you know it and you know it well, still watch the video, still take good notes, and that way, just in case you forgot something, it'll come back to you. So let's go ahead and get started with this on today's stuff. Okay, so here we're looking at variables and expression. You have a bunch of vocabulary words. If I were you at this point, I would pause the video and I would write out all of the vocabulary terms that you see there. So, hopefully you've already paused and just wrote them all down. Let's take a look at these. Some vocabulary words. A quantity, anything that can be measured. It's basically just a number. A variable is a symbol. It's usually a letter that represents the value or values of a variable quantity, something that can change. You see X often, or Y. And as you move up and you take more difficult levels of math, they start throwing in Greek letters like alpha and omega and beta and different letters like that. An algebraic expression is a math sentence that has at least one variable. Okay, it has to have at least one of them. A numerical expression is just numbers and operations, and it is nothing more than that. So let's go ahead and jump into this. All right, so here we're looking at writing algebraic expressions from a word phrase. So let's take a look at this first one, 32 more than a number n. Now, you should recall that addition, we're looking at more than, so we're talking about addition, but you should recall that addition is what we call commutative. That means the order doesn't matter. But in terms of the way this sets up, I want you to think about it. It says 32 more than a number n. That means we start with a number n, and whatever that number is, we're taking 32 more than that. So 32 is added to that n. All right, it's not, you could write 32 plus n, and that is the same thing, but this is better because this is how it's written. For the more than, again, because addition is commutative, it's not a big deal, but you'll see problems that say less than, and in that case, it is a big deal. Let's take a look at this one right here. It says 58 less a number n. Now that one's weird, right? Because we have this a instead of than. 58 less a number n. So in that case, less a is kind of used like a verb. So it means I'm starting out with 58 and I'm lessing that number, if you will. I know that's a weird way to speak, but I'm lessing that number by some unknown value of n. So that would be written out like this. Now, if you did not copy this down, what you need to do now is pause the video and copy all of this information. If you do not have notes in class when you're working on these things, I'm not going to help you. And you're also allowed to use your notes on your checkpoints, the graded portion of these assignments. So it's going to be very important that you take good notes. With you being able to pause the video, you have as much time as you need to write them down. So again, make sure that you are pausing and copying these things down. Example 2, writing expressions with multiplication and division. It says, what is an algebraic expression for the word phrase? And I have a couple of them here. I have 8 times a number n. There's a couple ways that you could write this. Okay, you could say 8 times a number n. You could say 8 dot n. I still remember being in school and learning that we could use dot instead of x for multiplication. These are both fine, but they're not the best. And what I'm looking for is the best. So the best way to write this, algebraically speaking, is to not have anything between the number and the variable. A number next to a variable means multiplication. So 8n is the best way. This one in particular can be troublesome, especially when you start throwing around other variables. Because what if you were going to say something like 8 times a number x. Well, then all of a sudden it becomes very, very confusing. Is that two x's or is it times and then the variable? I write my variables in cursive, so to try to eliminate that confusion, but still, this one right here is the best way to do this. I'd like you to get in the habit of that. The quotient of a number n and 5. There's a couple ways we could write this one. You could do n, and then you could use the divided sign in 5. Nothing necessarily wrong with that. I see students do this from time to time, n/5, and I think that's because you guys are a computer generation and you're used to and comfortable with things with the slash. But in my opinion, the best way to write this is as a fraction. So n over 5, n divided by 5. Remember, a horizontal fraction bar means division. So this one would be my preference. Again, hopefully you paused this and you copied down these examples. Let's keep moving. All right, example 3. What if there's two operations? What is an algebraic expression for the word phrase? 3 more than. There's that more than again that we looked at a couple examples ago. And then twice a number x. So twice a number means multiply. So I'm going to start out with 2 times the number x. It assigns me the variable. And whatever that value is, I have 3 more than that. So I start with 2x. And then I add 3. So I get 2x plus 3. This one, here we have 9 less than. Now going back to this problem, if I put 3 plus 2x, that would not necessarily be incorrect because, again, addition is commutative. But down here, when you're looking at less than, and you're dealing with subtraction, it is not commutative. The order is very, very important. So that 9 less than must come at the end of whatever happens over here. So here I have the quotient of 6 and a number x. Written in order would tell me I do 6 over x, and then it's 9 less than whatever this value is, so I'm going to subtract 9. So 6 over x minus 9 is the best way to write that one. This last one, I have the product of 4 and the sum of a number x and 7. This one's kind of strange. I have this sum of a number. What that tells you is that there's something that happens before I multiply with the 4. Hopefully you remember that product means multiplication. So that means I'm taking this 4 and then I'm multiplying it by something that happens with the sum. In other words, addition. And it is a sum of a number x and 7. So x and 7 are being added together, and then I'm multiplying it by the 4. Now, if you recall your order of operations, if I left this like this, you would multiply the 4 times the x and then add the 7. That's a mistake because that's not the way this reads. This reads it's the product of 4 and whatever that number x is plus 7 first. So in order to make sure that happens first, I'm going to put those values in parentheses. So I have 4 times the sum of x plus 7. Every now and again you'll see this where it will say the product of 4 and the quantity of something or other. In that case, almost any time you see the quantity or you see the sum of something or you see the difference of something, be careful because you're probably going to be putting something in parentheses. So just be aware that those kind of problems could come up. Okay, so example 4, look at this one. It says, using words for an expression, what word phrase can you use to represent the algebraic expression 3x? There are a few different ones. You could probably come up with a lot on your own, but I'm going to go ahead and give you just a couple. So one would be 3 times, I'm a cursive writer, so you're going to have to get used to that. 3 times a, number x. That's one, right? Because that's what this means. A number next to a variable means multiplication. So 3 times the number x. Or, because it's multiplication, a lot of times you'll see it phrased as the product of 3 and a number x. All right, so 2 different ways. I'm sure you could come up with different ways, and that would be great. There's just 2 that come at the top of my head, so hopefully you could come up with something Similar to that. Let's take a look at another example here. Okay, so example 5, it says writing a rule to describe a pattern. It says the table shows how the height above the floor of a house of cards depends on the number of levels. So here we have a diagram of this. Here's the house of cards. We have the card height being 3.5 inches, and then the height of the table is 24. Notice over here that this 24 is always added to that. That's called a constant in math, and we'll talk about that in more detail later on. But the question that we're going to be dealing with in this is, what is a rule for the height? Give the rule in words and as an algebraic expression. So let's first talk about how we could write this rule in words. Here you could see it's 3.5. That was the height of the card, and that happens every time. Here we have the number of levels. So in words, the way you could say this would be to multiply the number of levels, and I'm going to write this. That's not a hashtag. That means number. The number of levels by 3.5, and that means and, add 24. All right, so that's how we would write that in words. The next thing is you're asked to write it as an algebraic expression. So in this, I have the number of levels being represented by n in that chart. It says here, multiply the number of levels by 3.5. So if I have n number of levels, I'm going to have 3.5 times n, and then I add 24 to that value. So right here, this is my algebraic expression. So hopefully you paused your video and you wrote down this problem and then you wrote out the answer so that you have good notes. Because again, I will not help you if you do not have those notes. This next part here is a you-try, and you'll see this more as we go throughout the year. I didn't put a lot in this lesson just because it's such a straightforward, simple lesson. But when you see these you-try problems, the expectation is that you'll pause the video and you try the problem on your own. I'm not going to go over the problem. I'm only going to give you the answer. If you get the same answer, then great. You know what's going on. If you don't get it, go back and try to fix your mistake. And if you just flat out can't figure it out, these are great questions to bring to me the next time that we have class. So here's a you-try problem. Pause the video, read it, try to answer it yourself in your notebook, and then when you're done, unpause it, and I will review the answer to you. All right, so hopefully you've paused it and you've done the problem. So let's take a look. Your answer is going to be something along the lines of, you start out with that original expression, 34 plus 5n, and if you're adding another level of cards, since a level of cards is equal to 5, you would just add 5 more to that. And you can leave your answer like that. Some of you may have said 39 plus 5n where you simplified it, and that is perfectly fine as well. So that is it for our video in this first video. So hopefully you took good notes. I will see you in class, and when you come to class, you'll be getting your assignment, and we'll go from there. Thanks.